Have you ever had that super frustrating moment when your AI assistant just forgets something you told it like 5 minutes ago? It's a really common problem, and today that's what we're going to dig into. Not just why it happens, but the actual architecture that can give an AI a memory. We're talking about how to turn it from a forgetful tool into a genuinely intelligent partner. You know the feeling, right? Your AI totally forgets your preferences. It asks the same questions again and again, and pretty much every single conversation feels like you're starting from scratch. And look, this isn't just some random bug. It's a fundamental issue with how most of these AI models are designed from the ground up. So yeah, there's a name for this. We call it the AI amnesia problem, and it's all rooted in the core design of large language models, the LLMs that power tools like ChatGPT. But the cool thing is, once we understand what causes this amnesia, we can start to engineer the cure. Okay, so at the heart of the problem is one single word: stateless. What this means is that LLMs have absolutely no built-in memory of past interactions. They process your request, give you a response, and then poof, they completely wipe the slate clean. Every new question you ask is like they're meeting you for the very first time. And this whole stateless thing isn't just some geeky technical detail, right? It has real, annoying consequences. You can see it in these examples. An agent might double book your calendar because it can't remember what's already there. Or it'll completely forget that you prefer a formal writing style for your emails. It can even get stuck in a frustrating loop, trying the same failed search query over and over because it has no memory that it just tried that and it didn't work. So, what's the fix? Well, we start with the most common, short-term solution, which is creating something called an in-context scratchpad. You can think of this as the AI's immediate, working memory, what it's thinking about right now. So here's how this in-context memory actually works. With every single interaction, you feed all the relevant info for the current task, the whole chat history, your original instructions, any recent data, into the AI's context window. It's kind of like giving someone a full page of notes before you ask them to solve the next part of a puzzle. Now, on one hand, this is awesome. It's super fast, it's really accurate. But, and this is a big but, it has a critical weakness. It's totally limited by the size of that context window. As the conversation gets longer, the cost and the time it takes to get a response just keep going up and up, which makes it totally unsustainable for any kind of real long-term memory. So for a more permanent solution, for memory that needs to last way beyond a single chat, we need to give the AI something more. We need to build it a long-term memory, like a permanent library of information that it can go back to whenever it needs to. And this is exactly where external memory comes into play. Instead of trying to cram every little thing into that short-term scratchpad, we store key information in a totally separate, dedicated database. The AI can then just query this database to pull up relevant facts and context, pretty much the same way we might look something up in a notebook or a file cabinet. And this right here really gets to the heart of the trade-off every developer has to manage. In-context memory is immediate, lightning fast, and perfect for what you're doing right now. But it's tiny. External memory is absolutely vast and built to last forever, but it's a little bit slower because the AI has to take an extra step to retrieve the information. A truly smart AI needs to use both of these and use them well. Okay, so you've built this massive library for your AI. How does it find anything? Well, it basically has two main tricks up its sleeve. The first is semantic search, which is fantastic for finding general ideas. Searching for notes that have a similar meaning to the problem it's trying to solve. The other method is exact lookup, and that's for grabbing specific, hard facts, like finding a user's delivery address by looking up their customer ID. All right, so we've got our building blocks, right? We have the short-term scratchpad and the long-term library. Now, let's talk about how engineers actually put these pieces together to work reliably at a massive scale, creating something that starts to feel less like a simple tool and more like an actual artificial brain. Just like our own brains, a really effective AI needs different kinds of memory. It needs episodic memory to remember the sequence of what just happened. It needs semantic memory to store permanent facts, like your preferences. And it needs procedural memory to actually learn and remember how to do a task successfully. But this brings up a really, really important problem. An AI can't, and honestly it shouldn't, remember absolutely everything. It would just drown in useless data. So, how in the world does it decide what's actually important enough to store in that long-term memory? Well, the solution is to use some pretty clever tricks, or what we call smart writing patterns. For example, after a conversation is over, the AI can be prompted to summarize the key decisions and facts, and then it saves only that summary. Or certain events can act as triggers, like when you explicitly correct the AI. That correction gets automatically saved as an important new memory. But just storing the right info is only half the battle. The really hard part, the challenge that keeps engineers up at night, is making sure that memory stays useful and accurate over a long, long time. And this is where we get into the really tough advanced challenges. First, there's memory decay. How does an AI know that your favorite restaurant from last year just closed down? Then there's versioning. If you move, the AI needs to track that your address changed and use the new one, not the old one. And finally, there's multi-agent consistency. What happens when two AIs try to update the same customer file at the exact same time? Solving these problems is what separates a cool demo from a serious production-ready system. So let's put this all together. We have the short-term context, the long-term library, and these smart writing strategies. How do they all fit together to create one cohesive, working system? Probably the best way to think about it is as a memory stack. Right at the top, you've got that fast, in-context memory that's handling the present moment. It's the AI's active, working thoughts. And then layered right below it is that massive external library, always on standby, ready to pull up relevant history and facts from the past whenever they're needed. And that, right there, is the crucial takeaway from all of this. Building effective AI memory isn't really a data storage problem. It's an information architecture problem. The real goal, the whole point, is to design a system that can find and deliver the exact right piece of information at the exact right time. So that leaves us with one last, kind of mind-bending question to think about. If we ever actually succeed in building an AI with a perfect total recall memory, what would be the first thing we'd need to teach it how to forget?